Hello and welcome to our discussion of Module 2 in Big Data Technologies. Jumping straight in, Module 2 centers on the concepts related to special handling of big data. In particular, it's around file I/O within a big data environment. By the end of this, you should be able to demonstrate file I/O within a big data environment. And then furthermore, by the end of this, you should have some idea around what Hive is like, and talk about applications that read and write to data in a Parquet file, and then talk about the things related to writing things in a ORC or ORC file. So jumping into the module overview, talk a little bit first about what is Hive, Parquet, and ORC. Hive, it's a SQL-like sort of environment. It's not a database, don't think it is. But it's something that makes big data look a bit like a database. And so because of that, it's quite easy for people that are new to the field to start using it. Parquet is a type of file. It is columnar in nature, which means that things are stored in a column-wise sort of format. It's quite popular. It's used in a lot of different environments. ORC is used by Hive as the kind of the default. It was pretty popular for a while, but less so than it once was. So Hive, what is it? It's basically it's an entryway into big data. So it lets you essentially lay what looks a lot like a database on top of a big data store. Give me 1 second. Something popping up that I can wait on. So generally speaking, you use Hive for things like data exploration analysis, and it actually is also what's utilized in some environments like Databricks Delta to allow for even transformational workloads as well as data exploration analysis. And sometimes you'll do your work there and then do something to where you're exposing that data in something that's more high performance. So perhaps into something like a distributed data warehouse like Synapse or Snowflake. So key terms and concepts, Hive, we've talked about that. File formats, so that's simply a way that data is being serialized to the disk. Parquet being one of the more common ones. Optimized row columnar is ORC, right? And the distinction there, Parquet is going to be more associated with kind of higher performance sort of environments, and you a lot of times can mix and match your formats these days, but there's a lot of effort that's went into optimizing for Parquet. Types of databases and data stores, lots of different ones, but a common one here is a columnar store. So that data is stored essentially in columns. What that's really good for is if you're doing something like a group by or aggregates, and you're doing calculations that are by very nature columnar. What it's not good for is if you're doing things at a row level. So if you're wanting to do something like we typically do in a transactional database, not a great choice. So HD Insight, you need to know that because it's mentioned in your assignment. It's nothing more than an Azure hosted implementation of Hadoop. And used to be based upon Hortonworks, but it's a different distribution these days. But it's basically vanilla Hadoop. So the way that this works in a lot of domains is that organizations take what are essentially is the open source Hadoop project and do stuff to it to add value, and then also potentially turn around and charge for that additional value that they're adding. HD Insight is pretty close to what you would get if you go and you just download Hadoop like we've done when we were last week or this week Monday whenever we were talking about installing Hadoop inside of Windows Subsystem for Linux. Denormalizations is basically when you flatten out relational data. You do that to make it typically to where it's more performant in the way that it's being consumed. It's a trade-off. You're trading basically space for speed, but it's oftentimes something we do as a normal process. And in fact, the project I'm working on at work these days is all about basically creating these materialized views or persisted views for processing reasons. And the basic idea of big data is it's not about, oh, this is the cool shiny toy. It is about doing processing loads that can't be done some other way. Because of that, you are sometimes introducing latency. You may be just making it a bit more complex in some regards, but you have to because you can't do it another way. Drilling in a bit on Hive, it's kind of like a data warehouse. You can think of it that way, but it's a simplistic way to look at it. It allows you to write SQL-based queries that support all the things that you expect inside of SQL, things like a data definition language, so you can go through and you say create table, blah. You can do data manipulation, select star from, and you can create user-defined functions, UDFs, that allow you to do something that's beyond what you can do inside of typical SQL. You can basically what Hive is doing is taking that SQL that you're writing, HiveQL, and converting it into MapReduce jobs. And this is definitely not meant for transaction processing, and it does not do row level updates. So those are kind of the constraints. And here you can see kind of the infrastructure or the world in which Hive exists. And so you have at the bottom HDFS, so the Hadoop distributed file system backing all of this data, making it available for consumption. Then you have schedulers on top of that, Yarn, and then you also have this whole MapReduce, Tez, and Spark potentially above that. And Hive is kind of up on another layer and essentially creating either MapReduce jobs, or in the case of Databricks, which is actually using Hive as well, creating Spark jobs as well. So it's very much about a layer of abstraction so the developers can interact with it in an easy way. Parquet, it's a file format that was inspired by, as many things are in this world, by something Google did with their query system. It was originally built by Cloudera and Twitter. It is optimized for columns, and so it's a columnar data store, meaning that columns are your sweet spot, and you can compress them and you can split them, which makes them really compelling. It's used by lots of stuff, including Impala, which is an analytics database, Drill, Hive, Pig, and Spark. You put the metadata at the very end so that allows you to do one pass writing. So rather than to have like a header at the beginning of the file and then write some stuff and then maybe something at the end, you write everything at the beginning through, and then at the end you write what would normally be in some formats at the head. The reason being is you don't know some of that stuff till you're done. So you may not know how many rows there are until you're finished with the file. It's good for wide data, so if there's lots of columns, and it does support schema evolution, so that if something changes in what it does or what it means, then you're not out of luck. ORC, used to store Hive data. It stores a collection of rows in a single file column-wise, and so the column store allows you to access those columns that you're interested in and skip the ones you don't care about. You have this concept of a stripe, and that's a collection of rows of roughly 10,000 rows, and the whole point of this is you're kind of creating these chunks of data that improve the performance when you're interacting with the file system, be it HDFS or something else. And then the footer file is going to have your descriptive information about the columns that are in a given stripe, things like counts, min, max, and so on. And you can they're independent, and you can read a particular stripe that you're interested in without having to read all the others. HD Insight, cloud hosted, and key thing here is that you pay for it if it exists. So if you create it, somebody's paying for it, and since there's only one group of individuals bringing money to the table here, that's you. So you want to delete it when you're done. Just because you turn it off, it doesn't mean you're not paying. If it exists, you pay. It can access various types of storage, including HDFS itself, with its own sort of data store across the clusters, or you can reference external data, such as data lake and blob storage and what other types of storage you might want to use. So the basic architecture inside of HD Insight and Hadoop kind of in general is you have a head node. Generally speaking, you have two of those. You almost have two of everything whenever you're dealing with big data sort of systems because something can die. You also have worker nodes that are what are actually doing the work. And on each individual worker node, there's going to be a node manager. Then there's some other stuff that is created as well. But this is kind of the pattern that you may see. Whenever you're going through and creating a cluster, this will work if you actually go this route. And in a minute, we'll talk about your choices on the deliverable we're going to talk about. But you're going to want to go down to that A2 or the E2 for the head node and A2M for the worker nodes. It's not just because they're cheap, it's because there aren't as many processors available in the various regions as there once were. So you, generally speaking, you'll want to do the configuration that you see on the screen. So if you're watching this and you decide to go the HD Insight route for your project, then make a note of this, right? Because you'll need to do it, and you do not need auto scaling for your assignment. And what auto scaling does is as load increases, so do the number of worker nodes you have in your node. So you're going to want just basically the minimum of one worker node in this case. And also note, you can't really do a single node cluster in HD Insight because you have to have two head nodes and one worker node. You don't really have a choice on that. For deliverable 2, it's about file I/O in a big data environment. And you're still working at Big Data Connections, Inc. It's an international data clearinghouse that provides data services to thousands of its customers. DBCI's upper management needs to showcase examples of how data can be inputted and retrieved from big data repositories in order to attract additional clientele. DBCI's marketing department is developing a sales campaign to address big data, including how to read and write data in this environment and accomplish the various things that need to be done. You're one of the data scientists. You've been given the assignment of creating an application that reads and writes data into a big data environment so that the marketing department can showcase it. So you're going to create an application that reads to and writes data into a big data distributed computing environment. To do this, perform the following. You're going to go and create an Hadoop cluster of some sort, ideally single node, and we'll talk about your choices later on. And the link that's in those resources is not probably going to work for you, so don't get too excited about that. Extract, it doesn't have to be the background data file provided below, but you could do that. And import that data into Hadoop. If possible, use your local hard drive. You can't really do this as the data node and utilize Hadoop tools to manipulate the data. You don't want to do that. And then submit a Word document that describes your development process, including a screenshot to clarify your work. Some references, quick start creating the Hadoop cluster using a resource management template. When I tried that the last time, it didn't work. So you're probably going to want to do something else, but the other links might be helpful for you. You want to shoot for, obviously, the leftmost column. A thorough and detailed document has been developed that can be presented to the potential clients that discusses the application you've created and how it can be used to read and write data into a big data environment. The paper is free of errors and uses a professional tone throughout the paper. And then you've created an application that reads and writes data in a big data distributed environment, screenshots showing that it works and is free of errors. Those are basically your two criteria. So with that, I'll shift over to kind of your choices that you can use here. Where did it go? I have to end this to do this. Bear with me. One more time. Sorry about that. Here we go. So, talking about single node Hadoop. And the idea here is to not have to do a truly distributed network. In part, it's non-trivial to get a cluster set up and running, and that's one of the challenges with Hadoop. So there are lots of choices that you can do here, and I've outlined them, I believe all of them here. And so One of them, which is what the instructions say, is to basically use HD Insight. Another is to use a Linux virtual machine in the cloud, or a Linux virtual machine that's running locally to your computer. Or if you're running a Unix-based operating system, you can do it yourself if you're so inclined to just install it into your system. You can also do what I showed last week, which is using the Windows subsystem for Linux to do that, the installation there. You could even install it inside of Windows if you're running Windows, or inside of a virtual machine of Windows if you were more likely to, and there's probably other ways you can do it. If you go the HD Insight route, the pros, it's relatively straightforward. It's all in the cloud. You don't have to do anything locally. The downside is that it's kind of overkill for what we're doing here. It's also expensive, and you want to delete it as soon as you can. So that means you basically want to have everything together, go and create your cluster, do your work, then delete the cluster. A virtual machine in the cloud, it's the cons is you actually have to have either a VM that has Hadoop installed, or you need to download and set up Hadoop yourself. You're going to have an internet connection. The benefits is that if you turn off that VM, we're not paying for it, so it allows you to potentially take longer to get your solution done. But you do have to either find an image that has Hadoop installed, which is challenging, or you need to create your own. There are benefits. You can do things like snapshots and rollbacks, and when you're done with that, you can just delete it, so you don't have to worry about any kind of residue. The same thing is going to be true pretty much of a VirtualBox or Hyper-V running locally. So if you create a VM locally and do it, the downside is you're going to need some pretty good bandwidth, because some of this stuff is relatively large to download. You also may need a reasonably powerful computer to run the VM. So you're going to need to download an image that you would then create an instance of, and then you need to get Hadoop onto it as well. It's not the end of the world, but it is something that can be challenging. It used to be that you could download the Hortonworks, the Hortonworks Sandbox. That was a nice sort of one-box virtual cluster setup. It doesn't work as well these days. The Windows subsystem for Linux, there's lots of benefits. You don't have to deal with actually creating an image. Once you're done with it, you can uninstall it and delete, basically cleaning up your files. You can have access to your local hard drive, so you don't have to necessarily do as much transferring and such. The downside is you do have to download an image from the Microsoft Store, and then you have to get Hadoop set up and running. And that's not necessarily prohibitive, but it is somewhat challenging. You could run Hadoop inside of Windows. You can do it. It's supported, can be done, but it's not easy. When I say Hadoop is a Linux first sort of offering, that's where it came from. It does run inside of Java, so it can run pretty much anywhere. That being said, you have to do some work to get it to work inside of Windows. You can do it. It's running locally, perhaps lower requirements. You don't necessarily have to have a separate sort of a VM running or image of a VM and so on. The downside is when you're done with it, you may have stuff on your hard drive you may not really want to be there. And you could do the same sort of thing inside of a VM that is Windows locally. So you can be running a VM locally on your computer. That virtual machine could either be Windows-based or Linux-based. In both cases, you have to get that image of the operating or the virtual machine downloaded. Once you're done with it, you can delete it. So if you were going to go the VM route, you probably would want to go the Linux VM route instead. And so that is your choices. So I wanted to make sure that that's pretty clear, because I've confused people in the past. You definitely have choices on how you want to do it, and it's all about being able to meet these criteria of being able to create a paper. You don't necessarily have to. This talks about a particular data set. You can certainly use that if you're so inclined. You can also do something like word count. I'll certainly accept that as well, because word count shows that you've at least got a VM or an image of it running and can see it. So one of the things I thought might make sense is to pick up where we left off last week, which was around getting the Hadoop running inside of the Windows subsystem for Linux. As a reminder, so if you want to go this route, where you say add remove programs inside of Windows, if you're assuming you're running Windows, if you're not running Windows, then life is probably easier because you're on a Mac and you probably have native Linux support. There's a place here where you say that you want to turn on, and this probably looks a little different. I've been running a beta of Windows 11 for a while now. All right, where's it at? It was right there. Oh, they moved it on us. So basically, you want to go through here and find the enable Windows features. Let me get out of this and find the right spot. There we are. So turning features on and off, and you'll scroll down and you'll see Windows subsystem for Linux. Yours is probably not going to be checked. You'll want to check that. And that's, once you've done so, it enables WSL to work. Once it's done, you go into the store, Microsoft Store, search for whatever flavor of Linux you like. Ubuntu is always a safe bet. And you can pick either 18 or 20 LTS. Those are your best two choices. It really doesn't matter too much for what we're doing here. So you'll click on that, and like everything else, it'll go through sort of an installation process and download it. Once it's done so, it'll open it up. You'll go through the process of adding a username like I showed last week, of a username and password. Once you've done that, you're into it. You may also want to consider using what I'm using here, which is the Windows Terminal Preview. You can also install that from the store. What it does for you that's nice is you can open up onto multiple shells onto multiple sort of things. In this case, I can either go into 18 or Ubuntu 20 or Command Prompt or PowerShell. So it's a nice way of being able to open it up. So as I recall, where we got to last week was we downloaded, and if you're unfamiliar with Linux, CD tilde takes you to your home directory, so the directory where your user is. ls does a directory listing. Go into word count with cd, just like DOS, ls again, and you might be even, you can do dir as well. So ls is the more appropriate way, but enough people have been using this that they enabled it. And if I remember correctly, the last problem we had, one of the symptoms was this. So we were able to, in HDFS, DFS, LS, we were able to put the all right, let's start Hadoop, because apparently I need to redo that. So make sure that this is running. And you always check to see that you can SSH locally, localhost, and it worked. And you can also do SSH 127.0.0.1 if you were so inclined. It's the same thing. Localhost is the same thing. So if you ping localhost, it's pinging 127.0.0.1. So we then can go through and run through our startups, do all of our exports. Probably isn't necessary, but we'll make sure. Go and do, let's try HDFS LS, HDFS DFS LS. So we definitely need to start our services. So I'm going to go ahead and just try a start all. And if you were doing this in a real production sort of environment, you would modify your server so that it always started this stuff. As you can see, it appears that we actually are starting up some stuff. Give it a moment. And I'm fairly sure I missed the installation of probably the JDK is what I'm guessing. The fact that it didn't seem to like to compile the Java is why. So again, back here, we'll take a look at do an ls and see, yes, that time we can actually connect, and we'll take a look in input. And again, this is whenever I'm doing HDFS DFS, what I'm saying is take a look at the HDFS file system, not some local file system, because it might be that there's a Summers Day here, but it's a different Summers Day up there. So this is actually in Hadoop on its file system, and Hadoop needs to have access to those files in order to run. So we've got the thing that we want to do the word count on. Let's try this again to see if it's going to compile. This time it did. So whatever was wrong fixed itself. And then now we can also then run this jar command to create the word count jar. And then your last step here is to actually run the Hadoop command. So to break this down, what we're saying is we're telling Hadoop that we want it to run a jar, and in particular we want it to run the wc.jar. And inside of that wc.jar there is a class called word count that accepts two parameters. The first one is the input, which is summersday.text. The other is the output, summersday_count. We run that, and with any luck we actually are running. Okay, so in this case what happened here, and it did actually run, sometimes restarting things helps, and that may have been what's changed, because I didn't work on this image at all since Monday. I purposely left it so that we could figure out what was wrong with it kind of together. And the only thing that really changed was I rebooted my machine, and then we came back in and restarted Hadoop. So after we had installed the JDK at the end of our session. So breaking down what's going on here, looking through what it's producing. This is essentially the log files after we start the execution. Let's see if I can make that bigger. I don't think I can change the font. But we can at least see more of it at the same time. So it goes through a lot of stuff here you don't necessarily care about, but then we start going through and actually doing the work. We did some starting the flush. I think somewhere up here I saw something about splitting, number of splits. So it splits the file, then starts running it through. If you recall, we split the file, then we do the map, do the shuffle, then do the reduce, and then do the output. And then, so that's basically what we're seeing all here. And then at the end, you probably want to take a look at, and I really should have included it in my example, in the file. So we're going to want to do again the HDFS DFS ls output, and we should see the Summers Day _count, and then if we do DFS -cat output Summers Day _count, cat is the same thing as type in DOS. So apparently there's more than one file in here. So all I did was output the files that were produced, and you can see here these are the word counts, alphabetically ordered. Unfortunately, the case seems to matter because we aren't doing a low case, and we're also not cleaning up any punctuation. So the with a period after it is different than the without a period. So you would clean up your code. So taking a look at that code, And so the code here that you care about is the class I told you was word count. That's where this is right here. You know, so we say public class word count. And whenever we did the execution, we told it, look inside of this jar. And a jar is nothing more than a container similar to like a DLL from the Windows world. It's a binary container. Inside of that container, there is a class that was compiled to an intermediate level of code called word count. We want to run it, and that's what we're telling it. And so word count accepts in essentially two parameters. One of them, and you can see it here in the main, it doesn't explicitly state, I don't think that there are two, but it's basically, yeah, we can see right here we're going arg0 and arg1 at the very bottom of the screen. That's where we're saying the input and the output path, and that's the last two things that we pass in when we invoke the word count program. So that's that command broken down again, and kind of why it's that way. So pasting it in so you can see it again. When we say Hadoop, then we say jar. We give it the jar that we just compiled. We tell it the class inside of that jar that we want to run, and then any parameters that that class needs, the main of that class needs in order to do its thing. And in this case, all it's doing is going through and doing some tokenization, and then there's a map function inside of here that's not real smart. It's basically just getting each token, right? And then whenever we do and we basically say each token, and it's one. So that's literally a very simplistic way of doing it. Then we take those individual tokens and we do the reducing of them. And normally there'd be multiple nodes involved in shuffling going on and getting all the things that are the same keys together. This case, we're kind of running on one node, so it's less so the case. And then we just sum up the values of each one of those. And so it's literally just counting them, right? Then once we're done with that, that is the result, and we're able to then return the result to the file that's being produced. So that's basically word count. Moving into Hadoop in the cloud. And I'll talk about this repeatedly because, like I mentioned previously, this was challenging for some. So if you take a look in the resources, you can go through and say HD Insight Cluster. This is where you go to create one. You say you want to create a HD Insight cluster. You associate it with a resource group. This will be slightly different in your Azure subscription. I can see if I can get into mine so that we're seeing the same stuff. And you go to portal.azure.com if you're not familiar with it, and you'll use your SuperSites login. And it's been long enough that I've used this that I need to give it a new password. And with any luck, I typed them the same way. All right. Being a little picky. All right. I'm going to have it make one up for me. And don't be hacking into my account. I'll probably change that here in a moment. So when you go into your subscription, you'll type in I should have deleted that resource group, or it may already be gone. And no resources. This is just an empty group, but I want to clean it up so that we can go through, and so the next step will be to search for HD Insight. If you can type HD Insight clusters, and you'll see you want to create one. I'm not actually going to go through the process because we'd be here for a while. So inside of your subscription, you'll give it a name, something. Usually you want to create a new one and call it something like Allen HD Insight cluster or group. You give your cluster a name and where you want it to be. It doesn't matter too terribly much which one you want to do. Then you pick the type of cluster that you're wanting to create. In this case, you're going to be doing Hadoop. It's still checking to see if Allen is unique. We'll know in a minute. You want to also set your username. Admin is fine for what you're doing here. Give it a password that you can remember because you'll need it whenever you log in, and must have a number in it. You can leave the SSH username to be the same, and as I've talked about SSH with related to the Windows subsystem for Linux, it's just the means of communicating and connecting to a computer that's remote. You can also connect to one locally if you happen to have an SSH server running locally, but you can, the way that you would generally be doing your work, just as I was running commands here at a shell level, you'll be doing something very similar. You'll just be inside of an SSH shell whenever you're running them, rather than a command shell on the actual Linux box itself. So once you've filled out the first page, you go through and select storage. This matters because you want to put a name here, because if you delete your cluster, you may want to be able to come back in and reattach to it so that you can, what this is doing is creating inside of a storage account. This is where it'll be storing its files. If you don't do this, whenever you delete it, you're going to also delete your files, so you'll be starting back over from scratch. So you may want to do this as a means of simplifying your life if you go this route. The rest of this doesn't matter. You don't really care about this. Next, you need to do the configuration, and this is where I mentioned in that presentation, that's where this part comes to play. So you want to take a look at this screen, and then you want to basically set yours that way. So this doesn't have to be as big as that. It can be an E2 V3 that should have 2 cores and 16 gigs. You don't really care too much about what they're doing with the Zookeeper because it's free. You want to switch this down to an A2M. All right, A2M V2, and that's just basically a small computer, small core. It's only got 2 cores. It's only got 16 gigs of RAM. You only need one of those because you're not really going to be doing anything significant. Your next step is to go to the tags. We're not using tags for billing purposes or whatever, so you can do the review and create. Once this comes up, it's basically going to share with you everything that you just told it. You'll click on create, and then you're going to go probably have lunch or dinner because it's going to take about 20 minutes to create your cluster. Once that cluster is created, you'll go onto a page where you can actually connect to it via SSH and basically do the equivalent of logging onto it at a command line. And then you're going to be doing things very similar to what I've done inside of my Windows subsystem for Linux here. You're going to be running commands like Hadoop. You're going to be running HDFS, and you're going to be doing things like HDFS put and so on. So those are things that you're going to want to be doing a little bit of research. It's entirely up to you of which one of these choices that I've talked about you choose to go with for deliverable 2. The intent here is for you to have experience using Hadoop and having went through the process of setting it up and using it. So feel free to pick one. If you have any questions about it, let me know. That's what I'm here for. I'm not going to create this cluster because I don't really need it right now. As always, if you need have any questions about the material we've talked about or anything related to the course, let me know. That's what I'm here for. Stay safe, and we will talk again soon.